Hello friends, my name is Megha Sarode. In our last video, we have discussed the introduction of thermodynamics, system and surrounding, state function, and internal energy as state function. And today we are going to discuss branches of thermodynamics, laws of thermodynamics, and applications of laws of thermodynamics. So let's start with branches of thermodynamics. The study of thermodynamic system has developed into several related branches, each using a different fundamental model as a theoretical or experimental basis or applying the principle to varying type of systems. So first is classical thermodynamics. Classical thermodynamics is the description of state of thermodynamic system at nearly equilibrium that use microscopic or measurable property. It is used to model exchange of energy, work and heat based on the laws of thermodynamics. It represents first level of understanding as it was developed in 19th century and describe the change of system in terms of microscopic properties. Classical thermodynamics was the first level of understanding thermodynamics. It was introduced in 19th century and it was studied on the basis of microscopic property. Second is statistical thermodynamics. Statistical thermodynamics emerged with the development of atomic and molecular theory in the late 19th century and supplemented classical thermodynamics with an interpretation of microscopic interaction between individual particles. This field relates the microscopic property of individual atom and molecule to microscopic property of the material. And the third one is chemical thermodynamics. Chemical thermodynamics is the study of interrelation of energy with chemical reaction within the confine of law of thermodynamics. So we can say that statistical thermodynamics was supplement to the classical thermodynamics, and it interpreted the microscopic interaction with individual particle of the material, and chemical thermodynamics is the interrelation between energy and chemical reaction within the law of thermodynamics. Now let's study the laws of thermodynamics. First law of thermodynamics, also known as law of conservation of energy. This law states that energy can neither be created nor be destroyed, but one form of energy can be converted into another form. In other words, it can be interpreted as total energy of universe in all its form remains constant. For example, heat engine. Whenever heat is provided to engine, it converts heat into mechanical work. Therefore, whenever energy is applied to a system, it converts it into internal energy and useful work. Now let's discuss second law of thermodynamics. There are two statements for second law of thermodynamics. First one is Kelvin-Planck statement. This statement states that it is impossible to construct an heat engine working in cyclic process whose sole purpose is to convert all amount of heat supplied into equivalent amount of work. The process can be understood by this diagram. Here this is source which is providing heat to heat engine. Some work is done and remaining heat is passed over to the sink. So Kelvin-Planck statement says that whenever source provide energy to the system, it never convert it into work fully and remaining energy is given to the sink. The statement of second law of thermodynamics was given by Clausius and was known as Clausius statement. It states that it is impossible for a self-acting machine working in cyclic process to transfer the heat from a body to lower temperature to body at higher temperature without aid of external energy. So according to Clausius statement, it is given that we cannot transfer heat from body at lower temperature to body at higher temperature without external work. We can understood it by this diagram. Here sink is at T2 degrees Celsius and source is at T1 degrees Celsius, where T1 is greater than T2. So if we want to transfer heat from sink to source, we required external work working on the reservoir. Now let's see third law of thermodynamics. It states that entropy of perfect crystal at absolute zero is exactly equal to zero. Here the new word is entropy. So let's understand what is the entropy. So entropy is measure of disorder in the universe. So a solid is more orderly than a liquid because solid contains molecule in nice neat row. For example, ice and water. Ice is much colder than water, so entropy of water is more than the entropy of ice. So according to third law of thermodynamics, when temperature increases, entropy also increases. Now, zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two thermodynamic systems are each in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. So it could be understood by this diagram. Here there are three systems A, B and C. A and B are separated by isolated wall, and A is connected to C with conducting wall and B is connected to C with conducting wall. So there is isolated wall between A and B, so there is no transfer of heat or matter between A and B, whereas A is connected to C with conducting wall, so matter and energy exchange between A and C, and same is there with B and C. So all these three systems will be in thermal equilibrium with each other. Now let's see its application of laws of thermodynamics. First one is all types of vehicles that we use, car, motorcycle, truck, ships, aeroplane and many other types work on the basis of second law of thermodynamics. All the refrigerator, deep freezers, industrial refrigeration system, all type of air conditioning system, heat pump, etc. work on basis of second law of thermodynamics. All type of air and gas compressor, blowers, fan run on various thermodynamic cycles. One of the important field of thermodynamics is heat transfer, which relate to transfer of heat between two media. There are three modes of heat transfer: conduction, convection and radiation. The concept of heat transfer is used in wide range of devices like heat exchanger, evaporators, condensers, cooler, heater, etc. Thermodynamics also involves study of various types of power plants like thermal power plant, nuclear power plant, hydroelectric power plant, as well as plant based on renewable energy sources like solar, wind, tides and water waves, etc. In this video, we have discussed branches of thermodynamics, laws of thermodynamics and applications of laws of thermodynamics. In our next video, we will discuss in details applications of laws of thermodynamics. Thank you for watching our video.